Welcome back. This is the second lesson recording for IM1, November 10th, 2020. So where we've left off is in the card number 3 of the second Desmos exercise. Now we've looking for find the dot for the student with GPA of 3.0. So 3.0 will be here, okay? And ACT score of 23, and we've drawn the green line here. That means we are looking for 3.0. That means we are looking for points along here like so. And so my guess will be this will be my student with ACT score of 23 and GPA of 3. What new things do you notice now that the data is presented as a graph? Now that the data is presented as a graph, can you tell more as to how the spread of the scores are, maybe the trend? Okay, so those students who did better, who got better grades at school, okay, they also scored higher on the ACT. Whereas those students who scored low on their GPA, so they did not do so well at school, they were on the test itself, they did not do so well on the ACT as well. So that's what I noticed. And then finally, the fourth card said, what would you say is the relationship between the student's GPA and ACT score? Do you think there is a relationship there? Okay, how does the graph support your thinking? The students with high GPAs, their ACT score tend to be high. Okay, and the students with low GPAs, the ACT score tends to be low, would be my observation. Okay, all right, so then, okay, I'm going back to my slides. And so association, when two quantities are related, so when the quantities represented on the x-axis and the quantities represented on the y-axis, well, if they are related, we say they have association. Okay, students with high GPA tend to have high ACT score. That's what we notice. If students had high GPA, they also scored high because this is the cluster of students with high GPAs. And students with low GPA tend to have low ACT score. Okay, it's represented here. So, ways of describing association. We describe association with direction, shape, and strength. Those are the three things that we use. Direction tells me whether it's positive or negative. Shape is whether it's linear or non-linear, and strength is whether it's strong or weak. Okay, we're going to go more into this. But for now, can you just write this down? Okay, so association, how do we describe association? By direction, shape, or strength. So then we are going to go on to card number 5 to 7. All right, so then card number 5 to 7. For the same 100 students, we also recorded their height along with their GPA and ACT score. See? All right, so that we recorded their GPA and their height. Do you think students' GPA relates to their height? Do you think if a student was tall, maybe they would do better on their school? Or do you think if the students were short, they would do better on their school work? So do you think there is any relationship between those two? Okay, so yes or no, it's opinion question. All right, then here is the scatter plot of height versus GPA. So here they've actually recorded this. When they plotted this, again, each of those blue points represents one student. Okay, and there are 100 students. Okay, unlike the previous GPA with the ACT score, it looks like the dots are all over the place. They're just kind of scattered, okay? So does this graph support your choice from the previous card? It does not look like the students who did better on their schoolwork or higher GPA were taller or for that matter or shorter. They would seem to be a lot more random. So my thought is, yeah, I don't think it makes, the height does not make much difference to your GPA. So I would say no. What about this? Okay, Ben decided to investigate if there is any association between GPA and the number of days student is absent from school. Here's the graph he generated. So this time the GPA is on the x-axis and the number of absences is on the y-axis. That means students with many absences, they were absent a lot from many of the school days. Okay, the GPA was also very low. It was less than 1. Whereas the students with very few absences, like 5 or less, or maybe 10 or less, the GPA tend to be higher. Okay, so looking at this, you can kind of see the trend, can't you? Higher the GPA, the lower the absences. Lower the GPA, higher the absences, right? So does the data show that there is an association between GPA and days absent? Yes, because the data shows that there is a trend. So I'm going to say yes, there is a association, and you can explain the thinking. All right, then let's try to get sense of how strongly two variables are associated. Oops, I am not going to. Okay, so let's get back to the slides. So association direction. The association, when two quantities are related, the two quantities, if they move in the same direction, then we say it's positive. If it's two quantities move in the opposite direction, it's negative. What do I mean by that? So looking at this, the first one is the scatter plot of ACT. That's the ACT is the y-axis and GPA. Okay, so that's the very first one we saw. We noticed that the students who had low GPA also did not score very high on the ACT, whereas the students with high GPA also scored high on the ACT. So GPA and ACT scores have positive association. Okay, so that means as GPA increases, ACT also increased. So they moved in the same direction. Or if you think about slope, okay, what sort of slope is this? Think back to the slope, dude. This is puff, puff, positive, isn't it? Okay, so if I was to draw a line to say the trend, I might draw a line like this. Okay, so this is the positive slope, and we also say it's positive association. Now, if I look at the second one, I can say that that's the one where we looked at the height and the GPA. Were there any relationship between student height and GPA? No, there were not, because it seemed like the points were all random. Okay, so the GPA and height have no association. This one has no association. So I would like you to sort of draw something with just random points everywhere. And the first one, positive association, just put dots along as if it's along a line. And then lastly, GPA and absence have negative association. That means as the GPA increase, the absences decrease. Okay, so as GPA increased, the absences decrease. So they are going in opposite direction. So GPA is increasing and the absences decrease. So they're going in opposite direction. So it is negative association. It's almost as if I was to draw the trend line, it's going to go like this. And the slope, this is the nice negative slope, right? So this is the negative slope. That means we have negative association. So please copy this down as part of your notes. Okay, so positive association as the x-axis increases, y-axis, so they both increase, 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 or decrease, decrease. As I go decrease, go down, the ACT is going to go down as well. While as the negative association, as the GPA increases, the absences decrease. Okay, or as the absences decrease, GPA increased. All right, so then I want you to answer in private chat. When you look at this, do you see a positive association, negative association, or no association? No association is simply is when there are no pattern to it. There's sort of random dots everywhere. Okay, in this case, what does it look like? It looks like as the time played, so this as the time played increases, the point scored increases. So as the time played increases, okay, so it's going from 1,000 to 3,000. What happened to the total points scored? It increased from 500 to 2,000. Okay, so they both increase. That means it's positive association. Or if I was to draw a line along the dots, sort of rough line, it is increasing. It's increasing from left to right. So we say it's positive association. What about this? This is a scatter plot of video games. As the age increases, this time the video games played decrease. Okay, so when you're a teenager between 10 and 20, you played a lot of video games, but when you're in your 50s and 60s, you don't play much video games. So that's what this trend represents, these quantities represent. And as if you would draw a trend line of this, it's going down or it has a negative slope. So we say that it is negative association. What about this? The more cars there are the highway, the slower the other cars can move. If there are more cars, that means number of cars are increasing, but the cars are the speed is decreasing. That means it's going opposite direction, right? So this will be negative association. All right, what about this one? Okay, so the less time you spend running on treadmill, the less calories you won't burn. So if I spend less time on running, that means I am going to burn less calories. So as the time decreases, the calorie also decrease. That means it's a decrease, they're going in the same direction. So it's a positive association. Okay, so then I would like you to take notes on this. All right, so the linear versus non-linear. Do the points follow the shape of a line? This is a scatter plot. This will be linear because it looks like as if I was to draw a line, it would be a straight line. There is no association here because it just looks very random. This looks like this is a curved line. Okay, if I had to draw a line or sort of some sort of trend for this, it will be curved, while as this will be linear. It's fatter, but it's still linear. It looks like it's a straight line. So linear just means line. Notice the word line is the first four letters of the word linear. Okay, so that's how they are related. So at the end of the class, please write down today's date. We did two variable association. I'm sorry, we actually did this private chat as well. Okay, looking at A, B, C, D, these are scatter plots of different things. Okay, which graph shows nonlinear association? That means not a straight line. That would be B, right? Which line shows linear association? As if I was to draw a line for the trend, that would be a straight line here, and D would be a straight line here. So A and D would be a linear association. And that's all we covered for the day.